In unit 2, next topic is 6 pulse bridge converter, that is nothing but bridge circuit. So in 6 pulse converter or 3 pulse converter, whatever the converters. So in 3 pulse converter we having only 3 thyristors, that is T1, T2, T3 only. In 6 pulse converter they have 6 thyristors T1, T2, T3, T4, T5 and T6 thyristors. 3 pulse means in one complete cycles the output produces 3 pulses one for one complete cycle from 0 to 360 degrees from 0 to 2 pi radians the output produces 3 pulses. 6 pulse means in from 0 to 2 pi radians the output produces 6 pulses. So the number of pulses increases, the harmonic content in the output is decreases. Whenever the harmonic content is decreases, the required of filter circuit is less size. This is economical. So here we analyze 6 pulse converter. So in 6 pulse bridge converter we having 6 thyristors, 3 from positive group, another 3 from negative group. This is T1 plus 3 is T4, T3 plus 3 is T6, T5 plus 3 T8, that will comes to 2 T2. So upper is a positive thyristors, lower is a negative pulse thyristors. The currents are IS1, IS2, IS3. So this is a output voltage. So in 6 pulse converter means, so in there is a 360 degrees 6 pulse 360 by 6, every thyristor operates at an angle of 60 degrees. This is a basic operation. If this is a 3 pulse thyristor, 360 by 3, every thyristor operates 120 degrees. If there is a 24 pulse 360 by 24, so number of thyristor increases, the operating angle or firing angle changes. This is a basic operation. So we using the 6 pulse means 360 by 6. Every thyristor operates at an angle of 60 degrees. T1, T3, T5 operates on positive mode. T4, T6, T2 operates on negative mode. So by using the firing angle or delay angle, that is a 10 degrees or 20 degrees. So in 0 to 60 degrees, suppose the T1 operates 0 to 60 degrees. If you give the firing angle alpha is equal to 20 degrees, so in 0 to 60, at an angle of 20 degrees, the thyristor will be turned on. The thyristor will be turned on. Mean the controlling is possible in this by using the thyristors. If using the diodes, the control operation is difficult. There is no controlling by using the diodes. The control operation is possible only in thyristors. So normally we using IGBTs, GTOs for these thyristors. This grid circuit utilizes the transformer and the converter unit to most level, and it maintains low voltage across the wall when not in conduction. Due to this quality present in grid circuit, it dominates all other alternative circuits from being implemented in HVDC converter. Normally, if there is a 24 pulse converter also, 4 6 pulse converters we using. The combining operation of 4 6 pulse becomes 24 pulse. The combining operation of 2 6 pulse becomes 12 pulse converter. So the analysis of 6 pulse converter is very important. The low voltage across the valve is nothing but the peak inverse voltage which the valve should withstand. The 6 pulse grid circuit consists of 6 valves arranged in bridge type, and the converter transformer having tappings tappings on the AC side for voltage control. So what is the need of use the tappings? Tappings is in outside, in secondary side. Normally in transformer, tappings providing in secondary side. If the suppose there is a 220 kV transformer, there is a number of tappings are there. What we required voltage by using the tappings, we obtain the required voltage in secondary side. So this is also one of the controlling the voltage. AC supply is given for three windings of the converter transformer connected in star with grounded neutral. The windings on the valve side are either connected in star or delta with ungrounded neutral. The six valves of the circuit are fired in a definite and fixed order, and the DC output obtained contains 6 DC pulses per one cycle of AC voltage wave operation without overlap. So we have basically two conditions: with overlap, without overlap. First, we analyze without overlap. The 6 pulse converter without overlapping valve construction sequences are 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 1. The valves are operating 1 after 2, 2 after 3, 3 after 4, 4 to 5, 5 to 6, 6 to 1. So if the suppose thyristor 1 is in commutation mode, the current transfer from thyristor 1 to 2 means the current always transfer from positive thyristor to negative thyristor. This is the basic operation. 2 is a negative, 3 is a positive. The current transfer from second thyristor to third thyristor. The current always flows from positive group thyristor to negative group thyristors. At any instant, two valves are conducting in the bridge, one from the upper group and other from the lower group. Each valve arm conducts for a period of one third of half cycle 60 degrees. If one full cycle of AC supply, there are 6 pulses in the DC waveform. So this is 6 pulses. Hence the bridge is called 6 pulse converter. So what is meant by commutation process? Commutation process is a current transfers from one thyristor to another thyristor. Commutation process is very important in any circuit. How to transfer the current from one thyristor to another thyristor. That is a commutation process. Let SCR1 and SCR2 are conducting, and current is to be commutated from SCR1 to SCR3. So the current is transferred from 1 to 3. Commutation can take place as long as voltage difference of UB minus UA or VEB minus VA. The difference is in voltage levels. The difference is in voltage. Here the voltage we taken as UA, UB, UC. Thyristor 1, 3, 2. Positive, this voltage difference is referred to as commutating voltage. The commutating voltage can also be described as the reverse voltage across the SCR terminals that helps to turn off conducting SCRs. The commutating voltage drives the commutating current through SCR1 and SCR3. This commutation current will help increasing the current in SCR3 and decrease the current through SCR1. So what is the commutation process? Already I told that the current transferring from one valve to another valve. For simple analysis, following assumptions are much. First one is AC voltage at the converter input is sinusoidal and constant. So normally AC voltage is not a exact sinusoidal, not a constant, but we taken as that is a assumption. AC voltage at the converter input is sinusoidal and constant. DC current is constant. DC current also normally fluctuated. That small fluctuation we neglect that one. Third one, valves are assumed as ideal switches with zero impedance when on means conducting and with infinite impedance when off not conducting. In one full cycle of AC supply, we will get 6 pulses in the output. Each pair of the devices will conduct 60 degrees. The DC output voltage waveform repeats every 60 degrees interval. Already I told that there is a 6 thyristors, 360 by 6, that's a conduction angle is 60 degrees. Therefore, for calculation of average output voltages, only consider one pulse and multiply with 6 for one full cycle. In this case, each device will fire for 120 degrees. Firing angle delay. So firing angle delay is nothing but alpha. Delay angle is the time required for firing the pulses in a converter for its conduction. It is generally expressed in electrical degrees, in 20 degrees or 30 degrees, all are in electrical degrees. In other words, it is the time between zero crossing of commutation voltage and starting point of forward current conduction. The mean value of DC voltage can be reduced by decreasing the conduction duration, which can be achieved by delaying the pulses. By decreasing the delay angle, we can reduce the DC voltage and also the power transmission from one valve to another valve can also be reduced. When alpha is equal to 0 means the delay angle or alpha is equal to 0, the commutation takes place naturally and the converter acts as rectifier. When alpha greater than 60 degrees, the voltage with negative spikes appears and the direction of power flow is from AC to DC system without change in magnitude of current. When alpha is equal to 90 degrees, the negative and positive portion of the voltage are equal. This is very important. When alpha less than 60, greater than 60. Whenever alpha is equal to 60, the negative and positive portion of the voltage are equal, and because of above fact, the DC voltage per cycle is 0. Hence, the energy transferred is 0. When alpha is equal to 90 degrees, there is no energy transferred. So, the converter neither act as a rectifier nor act as a inverter. When alpha greater than 90 degrees, the converter act as inverter and the flow of power is from DC system to AC system. Let valve 3 is fired at an angle of alpha. The DC output voltage is given by VDC is equal VD naught into cos alpha. Take alpha is lies in from 0 to 180 degrees. So the difference voltage VD is equal to EB minus EC. So EBC is equal to root 2 VLL sine omega t plus 60 degrees. VDC is equal to 6 by 2 pi because we are using the 6 pulses. The alpha varies from alpha to alpha plus 60 degrees. Or change the firing angle also possible, alpha to alpha plus 30 degrees. If the firing angle is 30 degrees, 45 means 45 degrees. EBC d of omega t. So do it the integration. So we get 3 by pi integral alpha to alpha plus 60 degrees root 2 VLL sine of omega t plus 60 degrees d of omega t. By solving this equation neatly, we get the output voltage VDC is equal to 1.35 VLL cos alpha. VLL is a line to line voltage cos alpha. The alpha is varies from 0 to 180 degrees in converter station. So in alpha is equal less than 90, that is a rectifier. Alpha greater than 90, that is a inverter. Alpha is equal to 90, that will neither act as rectifier nor act as a inverter. The DC voltage waveform. The DC voltage waveform contains a ripple whose frequency is 6 times the supply frequency. This can be analyzed Fourier series and contains harmonics of the order h is equal to n into p. N is a integer, p is a pulse number, where p is the pulse number and n is a integer. Then r is equal to vh is equal to vd naught into root 2 by h square minus 1 of 1 plus h square minus 1 of sine square alpha whole power 1 by 2. This is harmonic content in 6 pulse converter formula. So this is a waveform, the output voltage waveform. Please see, whenever the alpha is equal to 0, alpha is equal to 45, alpha 90, alpha 135, alpha 180. So in 180, 135 we get the negative output voltages. Alpha is equal to 90, that will appears both positive as well as negative. In output will having both positive and negative. Half of output in positive, half of output in negative. Overall average is equal to 0. The net output voltage is equal to 0 when alpha is equal to 90 degrees. Whenever the alpha is 45 degrees, that is a positive. Alpha is 0, also a positive.